This is PreCalculus 12, Chapter 3.5. We're going to learn something new. We're going to learn something about inverse relations. And this is as opposed to functions. If we're given a graph, we reflect it on the curve, which is more strictly a line, y equals x. We can also take key points and swap x and y and plot. And then we mirror the curve between the key points. For example, we have this function, and we're going to mirror it on y equals x. So we start with this point. This point is negative 4, 2. So we go 2, negative 4. And you can see that this line is equidistant to this line. And this line is also perpendicular to this line. So there's a lot of symmetry going on when we do this reflection. Let's do this point. This is negative 1, 3. So we do 3, negative 1. And we should join these points because we have a lot of points and it might get confusing. This next point is 1, 2. So we plot at 2, 1. And again, join the points. And the last one here is 2, negative 1. So this becomes negative 1, 2, negative 1, 2. And join. And if we take any of these corresponding points, they should be perpendicular and equidistant to y equals x. And the domain and range shouldn't be a big surprise to you. We said swap x and y, so we swap the domain and range. So the domain of G is the range of f, negative 1 to 3, and negative 4 to 2. Let's check that out. And we start here at negative 1 and we go all the way to 3. And we start at negative 4 and go all the way to 2. So in general, we just swap the domain and range for G. And as I mentioned, we can check the reflection by drawing a line between the corresponding key points and check that they are equidistant and perpendicular to y equals x. And if you want full marks, you're going to draw these corresponding lines. You don't have to draw all of them, but you should draw at least a couple. And of course, we're interested in doing the inverse algebraically. So how do we do this? We swap x and y. So x equals 3y plus 7. Then we solve for y. So x minus 7. Positive 7 becomes negative 7 on the other side. And we divide both sides by 3. And put a box around your answer. And because this is linear, this is a function. So our y equals 2x minus 4 and y equals 1/2 x plus 6 inverses of each other. Well, we have to do the inverse calculation on one of the equations and check to see if it matches the other equation. So we'll take this one, x equals 2y minus 4. Bring the negative 4 to the other side, it becomes plus 4. Divide both sides by 2. This does not equal this equation. So they are not inverses of each other. Let's look at a slightly harder example. Again, we still start off by swapping x and y. Every y gets turned into an x. Every x gets turned into a y. Now we want to multiply the denominator to the left-hand side and expand. So 3y times x is 3xy. Negative 5 times x is negative 5x. Now we move all y terms to the left-hand side. So this needs to go to the other side. So we have 3xy minus 2y. This negative 5x goes to the other side, so it becomes positive 5x. Now we need to factor out a y. So y, 3x minus 2 equals 5x minus 9. And we isolate y, so we need to divide this by 3x minus 2. And this is a rational function, so inverse is a function. Let's look at an example with a quadratic. We still need to swap x and y. So the algebra is a little bit different here. We have to move the plus 5 over to the other side. So the way we solve for things in algebra, in case you didn't know, is we do bedmass backwards. So that's Sam, Deb. That means we do the addition and subtractions first. So this is done first. X minus 5 equals y minus 3 squared. Now we do the square root next, and that's an exponent, so that comes before brackets. So square root x minus 5, this becomes plus or minus. And now we have just the subtraction next. So y equals, this becomes positive 3 on the other side, so 3 plus or minus square root x minus 5. And whenever we have a plus or minus, this inverse is a relation. It's not a function. So let's see this with a plot. Okay, so we have, this really could be moved out here, and that would be our vertex, 5, 3. So we have 5, 3, and it's a square root, and we have minus a square root. And you've been told to use the vertical line test to see if a relation is a relation or a function. This goes through 2 points, so it's a relation. Now, if we consider this vertical line as the image, the pre-image is this. It's a horizontal line. So if we want to determine if the inverse of a function is going to be a function or a relation, we just do a horizontal line test. This is passing through 2 points, so even without graphing this, we can tell that the inverse is going to be a relation. Another problem that you'll have to tackle is how to make this function have its inverse be a function. Well, we need to limit the domain. This is another problem. Make inverse a function. So the only way to make this not cross 2 points is by splitting up the domain right there. So we can say x is less than 3, or x is greater than or equal to 3 to make inverse a function. So it's just one of them, but not both of them together. And what happens here is we get restriction y is less than 3 or y is greater than or equal to 3 to make inverse a function. And just to get this down in writing, an inverse is a function if it passes the vertical line test. However, we can tell there is an inverse function by doing a horizontal line test of the original function without graphing the inverse. So as a quick example, is the inverse of this a function? And is the inverse of this a function? So are the inverses functions? And that's a class discussion. And that completes this lesson.